Okay, so finishing up lesson 1, we're going to just talk a little bit about classifying polynomials. So again, these polynomials have specific ways to classify them. Are they quadratic? Are they linear? Are they cubic? How do we what do we name them? So far in algebra, we've only dealt with the first few kinds up to here is where, whoops, sorry, wait, get my pen. We've only dealt with things up to here, so between these. And so we've said anything that has a degree of 1, so remember a degree of 1 would be x to the first power, that was called linear. Okay, that was linear. And so x plus 3, so y equals, or f of x equals x plus 3. That was a linear function. And then this particular function has 2 terms, right? 2 terms in it, the x term and then the 3, so 2 terms. So we consider that to be a binomial. And you know what, maybe we'll come back and do the terms in a minute. Let's continue with the degrees instead for a second. So x to the first power was linear. X to the second power was our entire chapter on quadratics, where we learned how to graph a quadratic. And so in this particular example, f of x equals 3x squared. We don't have a linear term and we don't have a constant term in this example. But we could certainly put some in if you wanted to do plus 2x minus 4, something like that if you wanted to, just to make it look more like what your typical quadratic would look like. So x squared term is a quadratic. The 0 degree means x to the 0, and anything raised to the 0 is equal to 1. So that means that there were no x terms, and that was called a constant. And so we have 6 as our example of what a constant looks like. Okay? Then we're going to move up the chart a little bit and start talking about all kinds of special names we have for other functions. So we have constants, linear, quadratics. Then we move up here to the third power. So x to the third power is called a cubic. Think about raised to the third power, length times width times height. When you're talking about volume, you're talking about a cubic or a cube sort of shape, something three-dimensional, so we call this a cubic. X to the fourth power has a special name as well. We call this a quartic. Think about 4 quarters. Quartic. And that's a 4. My marker's not working very well. X to the fifth, we call this a quintic. And then after this, they're sort of on their own. They're just polynomials. We really don't usually say a whole lot. In fact, we very rarely even call quartics and quintics by name. We usually just say linear, quadratic, cubic, and then after that it's a polynomial of the 4th degree or polynomial of the 10th degree or the 6th degree or the 5th degree. But these are the specially named ones. Okay? And then so we classify polynomials 2 ways. We classify them by their name or their degree. So this section, all right, so by their name, the degree, so we call it by that. And then the second way that we classify them is by the number of terms that they have. Okay, so if we look at the second box, we kind of started off already, and I'm going to get rid of this example now because we're not using this in here to tell how many terms there are. This one had 2 terms, okay? This one, with the 6, has 1 term, and so that's just a monomial. And I think most of you know these. Mono for 1, bi for 2. This one has just 1 term, the 3x squared, so it is also a monomial. Okay. This particular function has 3 terms, and we know that anything with 3 terms is called a trinomial. 3 for tri. Again, the next example, our quartic has 2, and so we call that a binomial. 2. And then this one has 4 terms. So anything greater than 3 is just called a polynomial. So greater than 3 is a polynomial. Okay, greater than 3, poly. So we're going to practice using this in the first 4 examples on the top of the next page, where it says to write each polynomial in standard form. That means put it in descending order, then classify it by degree and by the number of terms. So I'm going to put this one, number 1, in order by degree. So x to the 4th is before x to the 1st. So 5x to the 4th, that's a positive 5, and then it's a negative 7x. And then I'm going to classify it by its degree. It's a 4th degree, so it's a quartic. And then there are 2 terms, so it's a quartic binomial. Quartic for the 4th power degree, binomial because there's 2 terms. Okay, let's look at the second example. I have some like terms that I do need to combine before I continue to move on, before I continue to decide what degree or number of terms there are. So I have 3x squared and 2x squared. That gives me, x to the thirds. That gives me 5x to the thirds. And then I have an x squared, it's positive, and then I have a negative 4x. So 5x to the third plus x squared minus 4x. It has a degree of 3, so it's a cubic. And there are 3 terms in the polynomial, so it's a trinomial. Okay, cubic trinomial. Number 3, I don't have any like terms. They all have different exponents, so I can't add them together, but I do have to put them in descending order. X to the 4th is the highest power, so I'm going to start with negative 3 x to the 4th. Notice you always take the sign with it. Then I have a positive x to the 3rd, and then I have a negative 2x squared. This is a 3. Okay? So I'm then going to decide it's a cubic, it's a quartic because it's raised to the 4th power. So quartic, and there are 3 terms, trinomial. Quartic, trinomial. And then the last one, x to the 5th power goes first, so negative 2x to the 5th plus 6. X to the 5th means it's a quintic. And there are 2 terms, so binomial. So you can see that when you are classifying these by both degree and number of terms that you're going to have 2 answers. It's always going to be a quartic binomial or a cubic trinomial. It's going to have 2 names, one by the degree and one by the number of terms. Okay? So the only other thing we're going to talk about in this lesson is graphing, and this is where it sort of gets hairy because this is completely new to you, and you kind of have to have an understanding of what these functions look like. So off to the side of your paper, maybe on the back of this page, I just want you to copy this down really quickly. So remember that linears are straight lines, and those are x to the 1st power. Okay. X to the 2nd power is a quadratic, and we know what those look like because we graphed those in the last chapter. So there's our quadratics. Okay? And you'll notice that whenever we're talking about just the basics, that they usually are heading upward, positive in the first quadrant. Okay? Positive meaning going upward. The opposite of that would be going downward. So this would be, when it's going down, remember, it has a negative x squared. So the end behavior, the end of what your quadratic looks like, depends on which way it's going. So, but for now we're just going to write down the basic ones. So this is what a cubic would look like. So cubic again is going to start positive, but it's going to go down and it's going to come up and then it's going to go down. So x to the 3rd would look, those functions would look like this, with sort of that bump in the middle. And then an x to the 4th, again, it's going to start here, down, and then up again. So x to the 4th, this is what a quartic would look like. So on and so on. You can notice the change, what's happening each time. So sometimes I ask students to do this, and one of my students a long time ago used to do this on his paper, and I thought it was a great idea. So this is a 1, x to the 1st power. And this is a 2, because there's 1 here and a second one over here, so there's 2 heading up. This is a 3 directions, so 1 direction, 2 directions, and 3 directions. So you can say that this part of the function is heading in 1 direction, then it turns and heads in a 2nd direction, and then it turns again and heads in a 3rd direction. And this one's 4. 1, 2, 3, 4. So if you count the legs, so to speak, and in how many directions your quadratic is turning, then that can help you to remember what it's supposed to look like. So just by knowing that it's going to have 5 legs, I can do a quintic, knowing it's going to be up, it's always going to start positive. The parent graph will always start positive, so it's going to be 1, 2, 3, 4, and 5, and then it'll head off in that direction. Okay? So this is what the quintic would look like if I were to draw it on the coordinate plane. And so you can keep going and going and going and figure out what an 1/8 or 1/9 would look like. The height of the maximums and minimums will depend on the function itself. For example, sometimes you'll have a quartic, or let's do a cubic for example. Sometimes you'll have a cubic that'll have very deep valleys, like that, and sometimes you'll have a cubic that'll have a very flat valley, like that. So those depend on whether the functions are being stretched or shrunk. So remember, they can look a little bit different from what the typical first one was that we drew there. Okay? So let's talk about graphing. Let me scroll my page up. We'll just talk about graphing for a little bit. These are going to be challenging to graph, only because there really isn't an easy way to do this at this point. We could certainly use a graphing calculator. If you have a TI-84, you can plug this function in and it will tell you exactly what it looks like. You may have to fiddle around with the screen a little bit to find the zeros of the function. Remember, that's where it crosses the x-axis. But for now, what we're going to do is just figure out how to solve these just very basic ones. Okay, so the first one, we have to get everything over on one side of the equation. That's the first thing that I have to do. So I have to get these to cancel. And then over here I need to put this in standard form. So I have my x to the third. I have my 3x squared minus x minus 3. So that's my overall function that I'm dealing with, okay, my f of x. And so what I have to do with this function is I have to figure out what all the zeros are. So remember, to graph it, I want to know where are the zeros, where are the solutions, right? Where are the x-intercepts? Now, that sounds exactly the same as when we were dealing with quadratics. We were always wanting to know what those zeros were. Where is it crossing the x-axis? So this is going to help us figure that out. We're going to graph it, and then we're going to see if we can figure it out. So how do we graph this? Well, unfortunately, there isn't an easy way except to draw a chart and plug and chug. And for those of you who have struggled with plugging numbers in to an equation and not getting the right signs out because you're not being careful about your signs, this is going to be a struggle for you. Remember that you should put whatever you're plugging in for x in parentheses, and you always do that thing first. So you're going to cube the x and you're going to square the x before you do anything else to the numbers. And so when I'm doing this and I have no idea where this function is going to be on my coordinate board, if it's going to be well over into quadrants 1 and 2, or well over, or quadrants 1 and 4, or well over into 2 and 3, I don't know. Is it going to be really high up? Is it going to be really, low in the bottom quadrants? I have no idea. So I typically will just choose standard numbers, whole numbers, and just kind of search and use my mind to help me figure out whether or not I'm choosing good numbers or whether I need to do a better job at choosing those numbers. So I usually will start with something like -4, -3, -2, -1, 0, 1, 2, 3, 4. Seems like a lot, and you could go every 2, like -4, -2, 0, 2, 4. But remember, you're trying to be precise and you want to know where it's going to cross. So I'm not going to do out all of the math for you for all of these. I'll do a few of them, but I'll let you know what the y should be so you know if you're doing them correctly or not. So if I do this first one, -4 times -4 times -4 gives me -64. And then if I do -4 times -4, I get a positive 16 times 3, which gives me a positive 48. And then I do a minus a -4, that's +4, and then -3. gives me a negative 15. So I'm somewhere below in the negative region, below the x-axis. At negative 4, I'm down here somewhere at negative 15. So I'm just going to put my arrow, because that's going to be the end of where my function is going. If I'm way down at negative 15, that's probably the side of my cubic that's heading way down here. Okay? And I'm going to try to figure out where the rest of my function is. So I'm going to try negative 3. And when I plug in negative 3, I'm going to get negative 27 plus 27 plus 3 minus 3, which equals 0. That's a root. So at negative 3, I'm at 0. I'm going to plug that in. And I know my function's doing this. Okay? And I know it's supposed to have the shape of the one I've drawn off to the left. So I know that it's going to head up a little ways, but then it's going to turn and start heading down again. So I need to keep looking for that spot. So I'm going to plug in negative 2, negative 8, plus 12, plus 2, negative 3 gives me 3. So now I'm on the positive side. So I've gone below the x, I found a root, I'm now above. So at negative 2, I'm at 1, 2, positive 3. Okay. So I'm still heading upward. I'm waiting for my turn to see when I'm going to start heading downward. So plug in negative 1. I get negative 1 plus 3 plus 1 minus 3, which is 0, which means I've found my second root. So at negative 1, I'm at 0 right here. So look, it must have turned right there at 3, and now it's heading downward. Again, I'm going to go down a little ways and look for where it's going to be turning up, because usually cubics are going down in this direction and up in this direction. So I'm looking for where it's going to be turning. Put 0 in. 0 plus 0 minus 0 minus 3. So I get negative 3, which is, again, a negative. So I've gone down. 0, negative 3. Down here. Okay. Plug in 1. So 1 plus 3 minus 1 minus 3 gives me 0. So there's a root. And that's probably my last root. How do I know that that's my last root? Because if it's a cubic, then typically it has 3 roots. Usually we'll cross at 3 rational numbers. Now, you can get cubics that do this, and so they cross at 1 rational number, but then the other roots are irrational. And we'll talk about that later when we get into doing those a little bit more. So we have the 0, the root, okay, and then you can keep going to see, is it going to keep heading in the upward direction? So when you plug in 2, you get 8 plus 12 minus 2 minus 3, or 15. That is definitely way up there in the positive direction. Then when you plug in 3, you get 27 plus 27 minus 3 minus 3, and you get 48. So it's clear that I'm now just cruising along in the positive direction, so I don't even need to worry about doing 4. I just know that at 2 I was way up here at 15, and it's just going to keep heading in that direction. And so I have found the graph and the 3 roots of my function. Okay? So the second example that we have is a quartic. So there's 4 terms in this particular function, right? So we're going to have to take a peek at what's happening, what does it look like, you know, how many times does it cross, all of that kind of stuff. So we're going to take a moment, and I'll let you work on that, and you can come and check with me after if you would like, but just give it a try and see if you can figure out what that graph will look like. Okay?